Good morning, students. Welcome back to our YouTube channel schoolquiz.com. As you know, my name is Danish Agarwal. As we have started our topics of chapter number 2, that is matter around us pure? Is matter around us pure? In which we have discussed so many topics, in which we have already discussed what is Claudius solution, what is true solution, and what is suspension. And today we will discuss the difference between all three, that is true solution, Claudius solution and suspension, which is very important question, so let's start. It is chapter number 2. Chapter number 2, that is matter around us, is matter around us pure, is matter around us pure. We have already discussed all the three topics, that is Claudius solution, true solution, and suspension, from which we can easily formulate a difference between them. So till now, if you haven't watched my previous all three videos of that topics, first go and watch that videos and then come to that video. So it will be helpful for you to understand, for the better understanding of the topic difference between all these three. First one is our true solution. First one is our true solution. True solution. Second one is our colloidal solution, and third one is our suspension. So as we have already discussed, what is a true solution? Nature of true solution is it is a homogeneous in nature. It is a homogeneous mixture. We can write it as it is a homogeneous mixture. Whereas we know what is a colloidal solution, nature of colloidal solution, it is heterogeneous mixture. It appears to be homogeneous, but it actually is heterogeneous mixture. So we can write it as it is a heterogeneous mixture. It is a heterogeneous mixture. It is a heterogeneous mixture. It appears to be homogeneous, but it actually is heterogeneous mixture. And suspension, as we already know, that it is a heterogeneous mixture. It is a heterogeneous mixture. It is a heterogeneous mixture. What was a homogeneous mixture? Homogeneous mixture in which the constituent particles are uniformly distributed all in the solvent. Whereas heterogeneous mixture, the constituent particles are not uniformly distributed. Second point is size of particles of solute is less than 1 nanometer. Size of constituent particles is less than 1 nanometer. And what nanometer is equal to? Such that 1 nanometer is equal to 10 raised to power minus 9 meter. 1 nanometer, it will be equal to 10 raised to power minus 9 meter. And its second property is that size of particles lies between 1 nanometer to 100 nanometer. That size of particles lies between 1 nanometer to 100 nanometer. And second one is that is size of particles is greater than 100 nanometer. That is, size of particles is less than 100 nanometer. In first one, true solution, size of particles is less than 1 nanometer. and in colloidal solution it lies between 1 nanometer to 100 nanometer, and in suspension it is greater than 100 nanometer. Now come to our third point. Third point, very important difference. Next is our third point. Third point is the particles are not visible. The particles are not visible. The constituent particles are not visible even with the even with a powerful microscope. Even with the powerful microscope, these particles are not visible even with the powerful microscope. As I have already told you, that the size of particles is very less. It is less than 1 nanometer. That's why we can't able to see these constant particles with the help of microscope. And its particles will not also be visible. Okay, so the particles are not visible even with the powerful microscope are not even with the power sorry the particles are visible with the powerful microscope, and its particles are very big and it can visible through our naked eyes. The particles are visible with our naked eyes. We can see their particles even with our naked eyes. We don't need any instrument to watch that particles or to see that particles. Next is fourth point says true solution does not show Tyndall effect. True solution does not show Tyndall effect. As I have already told you, what is Tyndall effect? The scattering of light by the colloidal particles is known as Tyndall effect. And they don't show Tyndall effect because the size of the particles is very small and they can't scatter light. So fourth point is colloidal solution shows Tyndall effect. Solution shows Tyndall effect. And here fourth one is suspension may or may not show Tyndall effect. Suspension may or may not show Tyndall effect. As I have already told you that the particles of suspension are very large. Suppose if we take sand in water, till now if sand is not settled down at the bottom, they show Tyndall effect. But after some time, when they settle down at the bottom, they further not show Tyndall effect. That's why we can say that suspension may or may not show Tyndall effect. Now we will move to our point number 5. Point number 5. Point number 5. Point number 5 is the particles do not settle down The particles do not settle down due to gravity. The particles do not settle down due to gravity. As their size is very small, they're constantly moving. They're constantly moving. And in this solution, that is, the particles do not settle down due to gravity. And fifth one here is the particles get settled down due to gravity. The particles get settled down due to gravity. The particles get settled down due to gravity. Next, our sixth point is that is the entire solution can pass through filter paper. The entire solution can pass through filter paper. And in sixth one is the particles can pass through ordinary filter paper. And its sixth point is the particles can't pass through the ordinary filter paper. In 7 point we will take one example of a true solution. That is, example is like salt in water. Here example is like milk. And here example is, for example, sand in water. So this is all about our today's topic, that is difference between true solution, colloidal solution and suspension, which is very important. So here are 7 major points which shows difference between true solution, colloidal solution and suspension. So this is all about our today's topic. So thank you very much.